Good day, everyone. Today we will discuss one of the fundamental principles of classical mechanics, Newton's third law of motion. This law, proposed by the brilliant physicist Sir Isaac Newton, revolutionized our understanding of how objects interact with each other in the physical world. So, let us dive deep into the essence of Newton's third law.
Newton's third law states that for every action, there is an equal and opposite reaction. In simpler terms, this means that whenever an object exerts a force on another object, the second object exerts a force of equal magnitude but in the opposite direction on the first object. This law highlights the unbalanced nature of forces and the interconnectedness of objects in motion.
Understanding action and reaction forces. To be better comprehend Newton's third law, let's break down into its key components, action and reaction forces.
Action forces. The action force is the force exerted by one object onto another. It can arise from various sources, such as a person pushing a box, a rocket expelling exhaust gases, or even the gravitational pull of the Earth on a falling object. The action force is directed towards the second object. Reaction forces. The reaction force, as the name suggests, is the force exerted by the second object back onto the first object. It is equal in magnitude but opposite in direction to the action force. This force is responsible for the observable effects we witness when objects interact. For instance, the recoil experience when a firearm is discharged. Action and reaction forces always occur in pairs, acting on different objects, and they have the same magnitude but opposite directions. These forces are simultaneous and interconnected. It's important to note that although they are equal in magnitude, they are applied to different objects and can have different effects on those objects due to differences in mass or other factors.
To further illustrate the practical implications of Newton's third law, let's explore a few examples.
For example, first example is jumping. When a person jumps off the ground, they exert a downward force on the earth. It's action force. In response, the earth exerts an equal and opposite upward force on the person. It is called reaction force, propelling them into the air. Next example is swimming. In swimming, when you push the water backward with your arms and legs, it is action force. The water pushes you forward and it is reaction force, enabling you to move through the water.
Formula of Newton's third law. The force between two objects always occur in the pairs, which it force having an equal magnitude by acting in the opposite direction. To understand the formula of this law, we need to break it down into fundamental components and explore its mathematical expression. The formula of Newton's third law can be stated as follows. F sub 1 is equal to negative F sub 2, where F sub 1 represents the action force exerted by object 1 on object 2, and F sub 2 represents the reaction force exerted by object 2 on object 1. The negative sign signifies that the two forces act in the opposite direction. This formula reveals a profound symmetrical and balanced interaction between objects. It implies that no force can exist in isolation. Every force has a corresponding force that counteracts it. The formula is a mathematical representation of the equilibrium of force, demonstrating that the total force in a system is always zero when considering the action and reacting forces. Next slide, please.
So for example, a 10 kg box rests on a smooth horizontal floor in contact with 5 kg box 2 is pushed with a horizontal force of magnitude F equals 30 Newton. What is the acceleration of the boxes? So first is F of x is equals to 30 Newton. To get the acceleration, it is equal to the force over mass 1 plus mass 2. So acceleration is equals to the force, which is equal to 30 Newton over the mass 1, which is 10 kilograms plus 5 kilograms mass 2. So acceleration is equals to 30 Newton over 15 Newton. So Newton is also considered as kilogram times meter per second squared. So the kilogram will be cancelled. So 30 divided by 15, it is equals to 2, then copy the unit meter per second squared. So the acceleration is 2 meter per second squared. Next is, what is the force of contact between the boxes? So f of x is equal to f2 equals m2 times acceleration. So f2 is equals to mass 2 times acceleration, which is mass 2 is equals to 5 kilogram, then the acceleration is 2 meter per second squared. Then if you multiply it, F2 is equals to 10 Newton since it is kilogram times meter per second squared. Next is for the force 1. To get the force 1 is 30 Newton is equal to F1 plus F2. Then after the derivation, F1 is equal to 30 Newton minus force 2. So the force 1 is equals to 30 Newton minus 10 Newton. So F1 is equals to 20 Newton.
In conclusion, Newton's third law of motion provides us with valuable insights into the nature of forces and their reciprocal interactions. By recognizing the existence of action and reaction forces, we can better understand the fundamental mechanics that govern our physical world, from the grandeur of rocket launches to the simplicity of our everyday.